Okay, so I'm going to make a recording real quick. I've been asked to make a recording on how to multiply and divide rational functions. The concept is extremely easy. It really is. Here's one thing though, that if you cannot divide or if you cannot factor, you're going to have a very difficult time with this. So if you look at number 1 and 2 right here, they're already completely factored out. Most of the time it's going to look something like this, you know, and even more difficult things to factor. So trinomials, binomials, difference of squares, sum and difference of cubes, stuff like that. But the point is, you need to remember how to factor. And it's really going to come into play in this unit when we're dealing with rational functions. So now, simply put, to divide a fraction, it's the same thing as, let me go ahead and look at, the white on this paper. But when you divide two fractions, like 1/2 divided by, let's say, 3/7, something like that. So the way you do that is you actually it's the same thing as multiplying fractions, except you just multiply by the reciprocal of what you're dividing by. So you flip what you're dividing by and you multiply. And when you multiply fractions, you just multiply straight across. So it's really simple to multiply. So 1 times 7 is 7, and 2 times 3 is 6. So 1/2 divided by 3/7 is 7/6. And the way you do that is you multiply by the reciprocal of whatever you were dividing by initially. Okay, so now with that explained, we're going to apply the same logic to this right here. So if I am going to multiply by the reciprocal, then really what I have here is going to take a second of writing. So that equals 2x minus 5 times x plus 4 divided by 3x plus 1, x plus 4. And I apologize if anybody on this video walks in. It might happen. Now I'm going to multiply by the reciprocal of what I was dividing by. So 3x, notice 3x minus 1 is up top. 2x plus 5 divided by 2x minus 5, 2x plus 5. Okay, now why I'm saying this is so easy is now that it's all written out, it's already factored. Next question would be, okay, is there anything to factor? But it is already factored in this case. So what makes it so easy now is because it's multiplied straight across, you might as well have all this stuff multiplied together. So for example, you might as well have 2x minus 5 times x plus 4 times 3x minus 1 times 2x plus 5, and just write it all in the numerator. Same with the denominator, straight across. So terms can cancel out, and they can cancel across. Like if this was a 3x plus 1, you could cancel that with this 3x plus 1 over here. Okay, so x plus 4 cancels with x plus 4. 2x plus 5 cancels with 2x plus 5. 2x minus 5 cancels with 2x minus 5. And all you're left with is 3x minus 1 divided by 3x plus 1. 3x minus 1 divided by 3x plus 1. And you just leave it like that. If you have two terms that are left on top, then write them side by side. Remember, it's more beneficial to leave it in the factored form because later on when we start graphing, this is telling you where your domain restrictions are. So it's telling you where your vertical asymptotes are going to be at. Or maybe removable discontinuities, but I'll explain that at a later time. Anyway, that's your answer. So all of this divided is just that. Okay, so multiplication, even easier than division. You don't have to flip and multiply by any reciprocal. You're just multiplying straight across. So next question, is everything factored? In this case, yes it is. So start canceling things out then. We have 3x plus 4 right here, 3x plus 4. 2x minus 3, 2x minus 3. 3x minus 4, 3x minus 4. So I'm left with 4 and x plus 4 on top. 4 times x plus 4 divided by 3, 2x plus 3. And we're done. And again, we're going to leave it in this format. I mean, you could multiply it out. Honestly, you could write it like 4x plus 16 divided by 6x plus 9. You could do that, but the benefit of this is knowing exactly where my vertical asymptote's at. So my vertical asymptote would be at -3/2. You'd have a vertical asymptote because that's a domain restriction. All right. Now let's factor some. Remember when you have a binomial, You're just looking, it's either difference of squares, maybe sum of cubes, sum of squares, or I'm sorry, sum of cubes, difference of cubes. But this binomial, first thing you need to do if you're going to factor is just pull out a GCF, and that's all you have on this one. And the GCF is 6. So 6 divides both 6x and 12 and leaves you with x minus 2. And so remember, once it's divided out like this, it should be able to multiply back in and get you right back to where you were. 6x minus 12. Okay, so that's that factored. This one, it again is just a GCF, like that. So 3x, 9. This one is just a GCF. So these are all the same type of factoring right here. 5x, 15. Okay, this one is 4x minus 8, so 4x minus 2. Okay, now keep in mind though, this was divide, so I need to actually flip this one. So what I actually have is 5x plus 3 over 4x minus 2. Okay, so now that everything is factored out and we've changed the divide sign into multiply, so we're multiplying straight across, we can just cancel. So I have x minus 2, cancel with x minus 2, x plus 3 with x plus 3, I have 6 times 5, which equals 30, over 3 times 4, which is 12. And if you want, reduce that fraction to be 5 halves. And that's your final answer. Okay, next one. Trinomial. So I have two numbers that multiply to be 9, add to be 6, x plus 3, x plus 3. So if I multiplied that out, I should get right back to where I was. Difference of squares, binomial. X minus 3, x plus 3. Guys, and if you have trouble factoring, then go back and watch my video on factoring. Okay, it's multiplication, so we're just multiplying straight across. So we've already got it all ready to go. It's factored out. We don't need to flip and multiply by a reciprocal because it's multiplication. So I'm just canceling terms now. There, here, 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 x plus 3, x plus 3. So if everything cancels out, then what does that mean? That means whatever was on top was the exact same thing as what was on bottom. Okay, that's what that means. So you have a number divided by itself ends up being 1. So you can put 1 over 1 because everything cancels, or number divided by itself just equals 1, so you can just put 1. All right, let's do one more, and I'll do a more difficult looking one. Let's just do number 10. Okay, factor everything. So I have x plus 2, x plus 5. I have 4 times x plus 3, difference of squares on bottom, x plus 2, x minus 2. Okay, all those are factored. This one's not factorable. It's multiplication, so you're multiplying straight across, so we're ready to go and start canceling things out. If it were division, all I'd do is flip these, and then I'd be multiplying straight across. So it's really simple stuff, guys. X plus 3 with x plus 3. All right, so I've got 4 on top times x plus 5 divided by x minus 2. And that would be my final answer. Okay, so I'm done explaining that. If you have more questions, you can come in to class. Again, the most important thing is your ability to factor when dealing with something like this. Your ability to factor will make this significantly easier. So you need to learn to factor if you don't know how to do it. One more thing that I want to explain on this video is domain restrictions. And this is very quick and easy. I'm literally going to do this very quickly. So what creates a domain restriction is knowing that you can't divide by 0. All right, so your rational function, the parent function, it looks like this. Okay, it looks something like that, and the function itself is actually avoiding 0 because y equals 1 over x is the parent function of rationals. And if x were 0, then you'd be dividing by 0. So you have a vertical asymptote at x equals 0. And your domain restriction, the domain of this function is it's a set of all x such that x can equal 0. So pretty much that's saying x can equal anything but 0. All right, so when you're looking at this, what you realize is if you can't divide by 0, then x cannot equal 1 because 1 minus 1 is 0. So looking at this denominator, x can equal 1. Looking at that denominator, x cannot equal 1. So which one of these domain restrictions matches? Part A. X cannot equal 1. So C. Okay, let's look at another one. Looking at this domain restriction, x squared can't equal 1 because 1 minus 1 would be 0 and you'd be dividing by 0. So what numbers multiplied by itself, because it's x being squared, what numbers multiplied by itself would equal 1? Those are the ones we're trying to avoid. So for example, if x is 1, 1 squared is 1 and 1 minus 1 is 0. So x can't be 1. I'll just write it right here. X cannot be 1. Also consider negative 1, because negative 1 squared is still 1 and 1 minus 1 is 0. So x can't be 1, x can't be negative 1 because of this. And when you look over here, x squared cannot be 0 because 0 times 0 is 0 and you'd be dividing by 0. So x cannot be 0. So three things on this one. X can't be 0 because of this, and x can't be 1 because of this, and x can't be negative 1 because of this. All of those numbers would cause you at some point to divide by 0. So x cannot be 0 or positive or negative 1. So this one's F. Right here, x cannot be 2 because 2 minus 2 is 0. And on here, x cannot be 2 again because 2 minus 2 would be 0. So this one is simply x cannot be 2. And so on and so forth. I think you get the point. Let's just do one more to make sure. This one, x cannot be 1 because 1 minus 1 would be 0. And this one, x cannot be negative 1. So x can't be 1 or negative 1. So the answer would be right here, B. X cannot be negative 1 or 1. Okay, so I'm going to flip it over now and look at these. Now, what's interesting about this, concept still remains the same. So, for example, looking at this one when multiplying, x can't be 1 or negative 1. When looking at this one when multiplying, x can't be 0 or 0. X can't be 2 or negative 1, so on and so forth. But when you get to division, the point is, eventually you're going to be multiplying by this thing's reciprocal. So, let's look at F. So because of this denominator, x cannot be 2. So because of this, x cannot be 2. All right, because of this, x cannot be, this denominator, x cannot be 0. Now, keep in mind though, so there's two things that x cannot be. But when you look at this, remember that you're eventually going to be multiplying by its reciprocal. So you're going to be multiplying by x divided by x plus 1. So that's what you're going to be multiplying by, which means that x also can't be negative 1. So there's three things that x cannot be. X cannot be negative 1, 0, or 2. It can't be 2 for this, it can't be 0 for this, and it can't be negative 1 because of that. And you're going to be multiplying by the reciprocal. So keep in mind, this is going to be a denominator at one point, and that is going to be a denominator. And that's where you're getting two domain restrictions. So your answer is x cannot be negative 1, 0, or 2. And that is all for this video, guys. Thanks for watching. If you have any questions, then just come in early in the morning and I'll be here to help you out.